Hey guys, it's Tiffany from SuperEasyMath.com. Today, we're going to talk about the quadratic formula. Solving using the quadratic formula. Video 3. Some things to keep in mind. When you're solving a quadratic equation, your goal is to calculate what x equals in that equation. You need to make sure that you start with an equation that's listed in standard form, which looks like this. ax squared plus bx plus c equals 0. The quadratic formula that you use to solve the equation looks like this. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Let's take a look at example number 1. Let's say I'm given the equation 21x squared plus 35x equals 10 plus 6x. If you remember, I just explained that you have to start with your equation in standard form, which looks like ax squared plus bx plus c equals 0. This equation is not in standard form, so we need to get it that way. The first thing I'm going to do is write standard form above this problem. That way I have something to reference to while I'm solving it. So I have ax squared plus bx plus c equals 0. When I see this equation, I think, okay, well, it looks like basically all of our terms are on the left side, and then the equation is set equal to 0. So I'm going to mimic that same thing with the problem that I was given. So right now, on the right side, I have a positive 10 and I have a plus 6x. Those need to be moved to the left. But if you remember, when you're dealing with equations and you start shifting stuff around and moving it to the other side of the equal sign, you have to use the inverse operations to do that. So I'm going to look at this 10 and I realize that it's positive. So I know the inverse operation of a positive 10 would be a negative 10 or subtracting 10, okay? So we're going to take 10 away from both sides of this equation. So subtract 10 here and I'm going to subtract 10 on the other side. I like to draw a line to clarify that we're getting an answer. So I have 21x squared plus 35x minus 10 equals 6x. I don't need to write the plus sign in front of the 6x anymore because it's positive, so that just can be left the same. I don't need to write the plus sign in front of the 6x anymore because it just represents that it's a positive value now. The adding 6x just means you're dealing with a positive 6x now. Now I do want to keep the fact that the 6x is positive in mind because now I need to use the inverse operations on it to move the 6x over to the left side. So the inverse operation of a positive 6x would be a negative or subtract 6x from both sides. So I'm going to subtract it over here and I'm going to subtract it also over here. Again, like I explained, I like to draw a line. These cancel out, so I'm left with 0 over here on the right side, okay? So now I'm going to take all of my 4 terms that are on my left side, and by those 4 terms, I mean the 21x squared, and then I have my plus 35x, and then I have my minus 10, and then I have my minus 6x. I'm just going to rewrite those again, but all on the same line. So that's going to look like 21x squared plus 35x minus 10 minus 6x. Now on my left side, I can combine like terms. I have a positive 35x or a plus 35x right here, and I have a minus 6x right here. These two terms both are x's, regular x's, not x squared or anything. So I can combine them. I cannot combine the 21x squared because that's a different kind of x. I have a combining like terms video. Go check it out if you're unsure of why I'm not including the x squared. I like to explain it as your variables are items. So your 35x is like saying, hey, you have 35 xylophones. And then your minus 6x is like saying, somebody came to buy 6 xylophones, so you have to take away 6 xylophones. Now you can't figure out how many x squared you have in this with those two because The X squareds are like deluxe xylophones. They're an upgraded xylophone, so you can't count them in your inventory of xylophones like you would your plus 35X or your minus 6X. They're a different type of xylophone, so they get counted in their own category. So when it comes to combining the terms, you cannot combine an X squared with a regular X. So now I'm going to rewrite all of this again, but I'm going to combine the 35X and the minus 6X. And I have 21X squared. This ends up being a plus 29X minus 10, and that equals 0. So now, after all of that, I've converted the equation that I was originally given to standard form. And so that means now I'm ready to start solving for X. So now I've erased everything from the screen and I've rewritten the problem in standard form right underneath the original problem. Now, because I know I'm going to be solving using the quadratic formula, I'm going to put that formula up at the top of my work area so I can use it to reference to. Now I'm going to clarify my terms. 21 is my A value, 29 is my B value, and negative 10 is my C value. I need to use those when it's time to plug numbers into this formula. I'm going to clarify it again over here. 21 is A, B is 29, and C is negative 10. Now it's time to rewrite the quadratic formula with these values inside. I have X equals negative 29 plus or minus the square root of 29 squared minus 4 times 21 times negative 10. All of that is over 2 times 21. Every number that you see came directly from the values that I told you that A, B, and C equals. When you look at your quadratic formula over here, you can see that you need to plug in those values in different places. So as far as my negative B goes, which is the beginning, what that tells us to do is write down your B value. Remember over here, I explained that B equals 29. But it says it wants the negative version of it. So I'm going to take that 29 and put a negative sign in front of it before I write it down. Then I write my plus or minus the square root of, I need to write B again, and I just said B is 29. This time there is no negative sign in front of B, so I just write B as its positive version, or maybe I should say as the version that B is given to me. So B is 29 here, and then I write my squared. Then I need to subtract 4, and the value for A is 21, so I put that right next to it, and I like to put parentheses to clarify that I'm multiplying here. If I were to write the 21 alone without parentheses, at a quick glance, if I wasn't paying attention, I might think that was a 421. Writing the parentheses helps clarify that this is not just one solid number. Then I have my negative 10 written down because it was my C value. Now underneath that, I'm going to write a 2 because that's just a part of the quadratic formula. And then my A value gets filled in, and A is 21. Now I'm going to multiply everything together that's underneath the radical. So I'm going to start by rewriting all of this. X equals negative 29. I'm just rewriting the negative 29 for now. I don't have anything to do with it yet. And then I'm going to write the square root of everything underneath here. Well, 29 squared is 841. And then I'm going to subtract that from everything over here. Now, if I were to multiply 4 times 21 times negative 10, I would get negative 840. But because I have negative 840, I have to realize that a minus, which comes from this minus sign, and then a minus directly after it from the negative 840 will create two minus signs right next to each other. We do not write two minus or two negative signs right next to each other. What you need to do is remember that that becomes a positive. So if you have a minus a negative number, that's going to end up being positive. So instead of writing 841 minus negative 840, this needs to be 841 plus 840. Now I'm going to write all of this over 42 because 2 times 21 is 42. Now, one more time, I'm going to simplify what I can. I have negative 29 plus or minus the square root of 1,681 all over 42. Okay, so I'm still not done yet, but I have run out of area, so I'm going to start with my problem up over here. I'm going to take this and make it x equals negative 29 plus or minus, and the square root of 1681 is plain old 41. 1681 is a perfect square. That means 41 times 41 gives you that number. So that means when it was time for us to take the square root of it, we will get plain old 41. Now my denominator is going to remain the same. It's going to be 42. Now I'm going to rewrite this equation, but in two different ways. If you look at the sign in the denominator, I have a plus and a minus. What this means is I need to write this equation one time using the plus sign, and then I need to write it again a second time using the minus sign. So this first time I'll write it in this same color. I have x equals negative 29 plus 41 over 42. When I simplify that, I get 12 over 42. And then I can simplify again and I end up with 2 over 7. So this means x equals 2 over 7. Now I'm going to do this same thing again, but I'm going to do the subtraction version of it. I have x equals negative 29 minus 41, and all of that is over 42. When I simplify that, meaning subtract the 41 from the negative 29, I get negative 70, and that's over 42. When I simplify that, I get it all the way down to negative 5 over 3. So this means x equals negative 5 over 3. Now what this means as far as our equation goes is if you were to plug in negative 5 over 3 as one of these x values from the original equation in standard form, or even the first equation they gave you, either one, you are going to get a balanced equation. As far as the standard form goes, if I were to plug in the negative 5 over 3, everything on the left side of the equal sign would turn to 0. The same thing is true for the 2 over 7. If I plug that in as the x values of the standard form, everything on the left side would turn to 0, which would mean our equation is balanced. There are no other numbers in the world that you could plug in to your x values that would give you the same thing. You could say that you have another number, but it would just be the maybe unsimplified version. For example, if you were to plug in the 12 over 42, that would give you 0 as well, but 12 over 42 is the same thing as 2 over 7. 2 over 7 is just like the most simplified version of the number. So the only two values that you could plug in to this particular example that's going to give you a 0 is x equals 2 over 7 and x equals negative 5 over 3. Now let's take a look at example number 2. Example number 2. So again, the first thing I'm noticing is my equation is not given to me in standard form. This is a problem. I can't use the quadratic formula if it's not. When the problem is in standard form, that lets me know what my A value is, my B value is, and my C value. So right now, to get it in standard form, I'm going to make sure that I end up with a 0 value on the right side of my equal sign, and all my other terms need to go to the left side of my equal sign. So my first thought is I can see that this x squared has a negative sign in front of it, so I want to add it on both sides because addition would be the inverse operation of subtraction to move it over to the left side of my equal sign. So I'm going to add x squared, and then I'm going to add x squared. And I put the plus x squared all the way to the far left because I like the equation to lead with my variable that has an exponent, and that's part of being in standard form. So I'm going to write x squared minus 3x plus 9x minus 27 equals 0. Now I'm going to combine anything that I can combine, and I can see that I have two regular x's. I have my negative 3x, and then I have my plus 9x. So I'm going to say x squared plus 6x minus 27 equals 0. So now my problem is officially in standard form. I've taken my original equation and I've turned it into standard form. X squared plus 6x minus 27 equals 0. Now, before I begin with my quadratic formula, I'm going to clarify my values. My a is going to be 1. There is no number in front of the x squared. So what that means is there's an understood 1 as a coefficient. Whenever you have a coefficient of 1, you don't have to write it. Then my b value is going to be a positive 6, and my c value is going to be negative 27. Again, I'm going to clarify those over here. So a is 1, b is positive 6, and c is negative 27. Now, I'm going to make sure I have my quadratic formula written so I can refer to it when I need to. Now it's time to plug these numbers into it. So I'm basically going to start off by rewriting my quadratic formula, but I'm going to put the values in instead of the letters. So I have x equals negative b, so that's negative 6, plus or minus the square root of b squared, that means 6 squared, minus 4, and then a is 1, and c is negative 27. And that's all over 2a, or in this case, 2 times 1. Now I'm going to rewrite this, but solving as much as I can. X equals negative 6 plus or minus the square root of 36. And then I would say minus whatever comes after, but I can see that if I have 4 times 1 times negative 27, I would get negative 108. And again, just like my last example, I'm not going to write minus negative 128. That would be two subtraction signs right next to each other. We're not going to do that. So we're going to turn it into a positive 108. Now I'm going to put all of that over 2 because 2 times 1 is 2. So I can just drop that 1 now. Now I'm going to rewrite this, but I'm going to add what is underneath my radical. So 36 plus 108 equals 144. And all of that is over 2. Now I've run out of room, so I'm going to start back over here. X equals negative 6 plus or minus 12 over 2. Now, just like last time, I'm going to solve this problem in 2 separate ways. And I'm going to do that because this plus or minus sign tells us to do it. So the first way I'm going to solve it is using the plus part of that sign. So I have x equals negative 6 plus 12 over 2. And that ends up being 6 over 2. And that just ends up being a plain old 3. So x equals 3. So that is my first solution. That's my first answer to this equation. There's going to be 2 answers though. Now I'm going to do the same thing, except I'm going to use the negative sign or the subtraction sign. I have x equals negative 6 minus 12 over 2. And that equals negative 18 over 2. And that equals negative 9. So that means x equals negative 9. So again, I want to point out when I did this, I did the exact same problem, but in 2 different ways because I used a plus sign one time and a minus sign one time. So I guess really technically you can't say it's the exact same problem, but it does have the exact same numbers. But the first time I dealt with those numbers with a plus sign, and the second time I dealt with those numbers with a minus sign. So at the end, I'm ending with x equals 3 is the solution and x equals negative 9. So just like I explained in the last example, if I were to plug either of those values into my equation, which is written in standard form, then I'm going to get a value that equals 0 on the left side. These 2 numbers, 3 and negative 9, are the only 2 numbers that will allow that to happen. You could have something that's equivalent to 3 or 9, like 6 over 2. If you were to plug those in, that would also give you 0, but really it's the same value as 3. So it's the same thing. Now let's take a recap. When you're solving a quadratic equation, your goal is to calculate what x equals in that equation. You need to make sure that you start with an equation that is listed in standard form, which looks like this: ax squared plus bx plus c equals 0. The quadratic formula that you'll use to solve the equation looks like this: x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Now you try. Comment with the correct answer below, then head over to my website and click on video answers to see if your answer is correct. Solve the equation x squared minus 3 equals negative 2x using the quadratic formula. SuperEasyMath.com. Don't forget to like and subscribe. Did you find this video helpful? You can support this channel by donating to Super Easy Math through PayPal. There's a link to it in the description section below this video and on the Super Easy Math YouTube cover photo.